Hi, good morning. How are you?
How about you?
Doing okay. Doing all right.
All right, so I have you here for trees.
Correct. Yes. Can you see my screen? I'm sorry.
Uh-huh.
Okay, sure.
Alrighty, so let's jump on in, okay? Oh, what language? Oh, you already updated the Java. Cool.
Right.
So I have an example piece of starter code here that is in Python. I used to write it for a bunch of different languages, and I had people show up in these interviews with languages I've never heard of. So it's just an example. You can write it however you want.
Understood. Okay. So what it's asking is that you're given a binary tree, and you have to basically you're adding up all of the nodes of that particular tree. Do I have that right?
All of the nodes.
You're adding up I understand from root to leaf.
Yes.
Okay.
Yes, you're building a number based on the root to leaf paths, like 1, 2, and then 1, 3, 5, and then 1, 3, 9, and you're adding those numbers up.
Okay. Understand. Okay. So what I would do in a case like this, I would probably use a I could probably say basically I could use a traverse so traverse it and then go back to the root. Traverse the so in other words, for this example right here, I would traverse root to left, then come back. Oh, sorry.
You're fine. You can do whatever you want. I just try to provide examples to make it
All
clear.
right, appreciate it. Yeah, then I will come back and do root to right node, right node, to left node. And then to right node. And then so okay. I have to go back to the root again and then keep going even further. So I could probably I couldn't do that. I would have to go from root to root to node, root to left node, then root to right node. And then from there, root to left node, root to right node again.
Mm-hmm.
So you're going to have some recursion in this problem. Okay. Might even say DP, but I would say recursion for right now. So
trees pretty much always lend themselves nicely to recursive solutions. It can be done with or without recursion.
Right. But recursion is obviously easier, especially for our time complexity. So so we're returning the sum here, correct? So static. Binary tree. DTN. And then also teacher. Right now, CN. Then what I could probably do is I could probably put them into an array and add up the values up in an array. array list. Does my solution make sense? What I'm saying? So in other words, what I'm saying is this. What I'm saying is this. I'm going to go from the root to the left left subtree,
Mm-hmm.
then go back to the root, then go from root to the right subtree, and then keep going either left or right at that point, and then go back to the root again, and then if I went left before, I'm gonna go right this time.
Mm-hmm.
Does that make sense? What I'm saying?
Yeah.
So I'm going to put my values into an array list and add up those values. My solution makes sense?
I believe so. I'm not sure I quite follow the array list part.
Oh,
So you mean that you're gonna add so in here?
in other
Oh
words,
wait, wrong window. In here, you're gonna add like the 12, and then the 13, and then at the end you'll add up everything that's in that array list to get to 25, right?
correct, yes.
So my question to you is, how are we tracking? So we start here, and then we have 1, and then we're here and we have 2. How are we putting those together? Where are we tracking this 1? So we have 1, we have 3, we have 5. We get down to 5. We now need to build this number to put in your array list, right?
Correct, yes.
How are we tracking that 1, that 3, and that and the 5 to
Well,
build our number?
I'm going to add them to the array list.
Okay.
So in other words, what I'm going to do is okay. So we have.
I may be misunderstanding, so go for it if you have it. It's okay.
Well, let me try to help you visualize what I'm saying. That's so. First, for my base case, I'm going to say is if t equals then
You can just return 0. It's fine.
right. Yeah, exactly. Because that's basically a base case, just to, so they have it. Then you say, okay, if Tn not no, okay. Then what I'm going to do is I'm going to I shouldn't call this add. That just that's kind of stupid. What I'm going to do is I'm going to add get. I'm going to get the values of the binary tree and put them in here. And then what I'll say is just make sure I understand this because I have to do left and right. So I'll do putting the values of the left root into my array list.
I'm listening. I'm watching. I'm trying to
No,
follow along. I don't quite follow, but
I hear you. So then what I would do is So I would say now I have to add up the values of that array list. Then from here, what I would do is take those values. Think about this now. Because I want to be able to add up the values. Then go back. Put that add up values on the array list. Um, Hold on a minute. Add up the values of the array list. Oh boy. Add the values in the array list. Okay, this will add up the values of the left side of the tree. Go back to hmm, hold on. Okay. Push all those, push the BTN into this new binary tree right here. And here, then from here, see,
So
what were we going to say? I'm sorry.
so right now you're just worried about, or maybe I'm getting a little lost in where you're going with this.
So right here, this is my root left right here.
Mm-hmm.
Okay, or BTN left, I should say. Okay, so I'm getting those values, and I'm adding them up.
Mm-hmm.
Okay, now I'm going back to my root here. Now I'm going to work on root
I
BTN
think
right.
that might be the part I've been struggling to understand. Why are we? What do you mean by we're going back to the root?
Well, because like you said in our example, we're going from root to leaf, right?
Yeah. So we
So that's
have
a
1 and 2, okay.
right.
But now we have 1 and 3. Why aren't we going to 5?
Well, that's what I'm saying. We have to go. This is the left. This is the left side right here. Now we have to do the right side.
Mm-hmm.
So that's why we're going back to the root, because we have to go from 1 to 3 now.
Yes.
That's why we're going back. Does that make sense? What I'm saying?
Not exactly.
Doesn't make
So like,
sense.
okay, what is the point of your for loop?
Okay,
So we get the left node, right?
correct. Yes.
What are we doing with this for loop?
So the point of this for loop is that we're adding the values of root to root to left. Basically, that's the point of this for loop. We're putting the values into the array list, and we're looping through it, and we're adding the values.
It's been, I don't know, 12 years since I've done Java.
Mhm.
So maybe I'm misunderstanding, but the way I read this is let's say we had that 1 and 2, right?
Correct. Yes.
You're adding 1 plus 2, so this is 3 and not 12. And also, if this was, if this had yet another subleaf under it, like let's say a 3, we're adding that 1 plus 2 without actually continuing down the path to get any more leaves. Does that make sense?
Yeah, I see what you're saying.
So I don't think this part is right. We have the right idea. If we have nowhere to start, the root is null, return 0.
Right.
Otherwise, we should be like, okay, do we have a left subtree? If so, let's go that way, whether we do recursion or we're using a stack or however we're going to traverse this tree. And then let's check right.
Okay, so let's go back. Let's go back then. Let's go back and start over again. Okay, so boot left, binary tree left is not null. Then we want to return btn dot left. We're going to return the btn dot left. Return that. We're going to return 1 and 2, so to speak. We're going to return 1 and 2. Okay.
If a left is null, why are we returning a left?
No, I'm saying it's not null. Not.
Oh, sorry. Okay.
Not null. We're going to return btn left. Okay. Same thing if right is not null. We'll return right. Okay. So now we're getting everything from here and here. Okay. So we're getting both of them at this point. Okay. Then at this point, what we want to do is to add the values up. So our integer n we have to add those values. Hold on. The problem is that we're going to have to. It's still seeing it as 1 plus 2. So we're going to have to add 10 to it. So we have btn left. So let's say, for example, btn tn dot left. Then whatever that value is, and plus no. I don't think we really need to write the array list at this point. I'll take that out. Because with the n, by adding it up, we have to be able to add up. I know I missed something.
So you see where I have highlighted?
Yeah.
So where was I? So yeah. If the left node is not null, we need to continue down that path. So I don't think returning it is the correct thing.
Okay.
Same with line 59. If we have a right node, we need to continue doing work there.
Okay.
So and one of the reasons I was
go ahead, I'm sorry, go ahead.
I was gonna say, so part of there's a couple different parts we got to figure out for this to solve this problem. One is how are we going to traverse the tree, correct?
Correct, right.
Secondly, we have to figure out how we're going to build. So I'm gonna scroll, if you scroll up a little, we have to figure out how we're gonna, on line 33.
Oh, sorry.
We have to figure out how we're building these numbers, right? And that's kind of what I was asking about earlier. Now, whether you build it as a string, whether you and then convert it, whether you add the numbers and multiply by 10 or something, you know, we have to figure out how we're building those numbers. And then we have to either store them or add them somewhere, right? So there's three parts.
Right.
So right now, let's just figure out how we're going to traverse the tree.
Okay. So we have one, as an example, we're 1 and 2. And you're right, like you were saying before, might have to add 10 to them. Kind of like, well, not add 10 to them, but
multiply by 10.
Right.
So that we can increase the I can't think of the term, but you know, because it shouldn't be 1 plus 2, it should be 10 plus 2. So we have to increase it by multitude, power, whatever.
The multiplier. I know what you're saying. Multiplier. Right. So I hesitate to just say times 10 because that's a little bit too simple. But because what if you had 3 numbers there? Then you know.
Well, I'm not even talking about the adding right now. How are we going to traverse left? Because we can't just return.
Yeah.
Left.
So as far as traversing it, what I was going to do before is put it into an array list, or we'll put it into a stack. Either or is fine. Mm-hmm. A stack with an array list is fine. So for example, let's for right now. Let me comment this out. For right now. So for example, binary tree node. Let's put it into a stack. And then we'll say tree. This will this will say where we at btn dot push. So we're gonna push everything into this new stack right here, this new binary tree right here. And then from there, what we're going to do is to go through this tree, we could use a for loop, or we could use but no, an array list. Or this tree right here can actually do it. So this tree right here would have everything inside from the BTN inside of it. So from here, we have everything inside the BTN, and then from here, we could probably separate what we want and take out of it. Okay, so we have this array list right here. Right now, everything is inside this tree. And we're going to see. So putting the left side into the left tree into this array list. Does that make sense? Make sense what I'm saying?
Yes and no.
Yes and no.
So you're using this list to track the nodes that need to be processed.
Right, exactly.
But we're also making a new binary tree. Oh wait, I keep you're sharing your screen, so I keep trying to click your screen. So we have our new you're making a new binary tree, but then I'm not sure what you're pushing. I'm not sure why we need a new binary tree.
Well, we don't need it, but the reason I created one is just to make it easier to follow the code. This new tree right here is basically everything from this tree put into it. So I'm pushing BTN into this new tree.
Okay.
Just to make it easier to follow. But you're saying it's not easier to follow.
It's okay.
And then from there, I'm putting the left part of this tree into my array list.
Okay. So you're going through the original tree, and then you're putting that into a new tree that's basically like a straight line, and from there you're also pushing it into this array list.
The left side into the array list. The left.
Okay.
So in other words, right now, I'm separating the left from the right. That's what I'm doing right now.
Okay.
Okay. And then from there, I still have to add up the values, which is becoming the issue right now. All I can think of is a for loop. I take the values of the for loop. It would help us if we multiply it by 10. But then if we have three numbers, I multiply by 100, and so forth and so on. Say this like 4. Let's do it. I guess what I would have to do is I have to have a variable that tracks how many levels there are to root's leaf.
You want to call it here and we can just talk a little bit? Or do you want to keep trying?
Yeah, we can call it here because I'm
Okay.
stuck on this part right here.
It's okay. How comfortable are you with trees and recursion?
I'm somewhat comfortable with them.
So I would suggest practicing recursion. So like my first class in university, but the
Okay.
benefits is like dealing with recursion in trees is to me very easy just because I basically spent a semester living in that world, right?
Okay.
But the reason I'm saying this is if I would suggest you practice recursion because it'll make all of the tree stuff much easier in general. Now it's true you're not going to be deploying recursion into prod, but it'll make solving these kinds of problems much easier and helping you understand them. We didn't really get to debugging or time analysis. That's okay. If you're not sure, like if you're like working on a problem, like something needs to be sorted, ask them. Like, do you want me to write this sort, or can I use the built-in tooling? Because I had one where they wanted me to write the sort, and I had one where they're like, "Why are you writing this sort? Why not use the library?" I was like, "The last guy wanted me to write it."
Okay. Right. I got you.
um, what questions do you have? What can I do to help you? What parts maybe of this question you didn't understand? Would you like to walk through this question, and maybe how would that help you understand how
No,
this stuff can be approached? Or
I mean, as far as I mean, I understood what you were asking. I guess, like you said, that the hang up part of it was just like you said, making this 1 2 into a 12. I think that things like
so the
that.
typically way I have seen this done in Java. Again, I haven't coded in Java, or this. Sorry, I've had multiple interviews today. I think this was the last interview. I haven't coded in Java since college. So it's been about 12 years. Okay.
Gotcha. Okay.
As I rec, but the tool I have seen when I give this question and people answer in Java is use a string builder. Every
Mm,
time you recurse down, they're adding that new number. Like so, at the I'm scroll up a little.
sure.
I'm at the second example. So like string builder is just a one, and then they go left. They append a two, and then there's no new leaves. So they build a string out of that string builder, and so now they have the string 12, and then either they add that to a list that they process and sum all at the end, or they immediately add it to some like class variable. That's the total.
Okay.
Does that make
Yeah,
sense?
it makes sense.
So yeah, that's where when you were asking about having, I forget what you had. You had like an array list or something. I was like, that
Yeah.
could work, and then you convert it at the end into an actual number. But we still, okay, now we have 12. Where were you adding that? And that's what I was trying to understand, and I
Right.
wasn't quite following. But yeah,
Understand.
that's how they did it as a string builder. Add all of the 135, and then no more leaves. Convert 135 into a full string. Convert that to an integer, and then add it to a list that gets summed at the end, or just immediately add it to some total somewhere.
Okay. That makes sense. I guess for me it was like I was thinking because you have 1 2 here. I was thinking just if you had like 1 2 and then you had another um you know sibling for this.
Yeah.
That's what I was thinking. So what you
Another
can
way to do it is they'll have like they'll have that class variable total, but as they go down, they have one, and then now we're sorry, I need to scroll back up. We have the
sure.
one, and then now we're here. So now it's like, oh, take the original number one times 10. That gives us 10 plus 2. So now we have
Right.
12. So that works.
That
So
makes
that's
sense.
another way is like 1, 10 plus 3 is 13. Now we
Right.
have 13 times 10 is 130 plus 535. So no matter how you do it, but you have to do a little bit of bookkeeping along the way.
I understand. I know what you're saying.
You
Okay.
can find this on Leak Code. Pretty sure I saw it on Leak Code. Maybe I got it out one of my interview books. I have a couple of interview books and Leak Code that I went through to find my various questions.
Okay.
Honestly, I wasn't even sure if you knew how to go through the tree. So make sure you practice that. Like, be comfortable traversing through the tree.
Okay.
That's why I was trying to ask you, like, could we just traverse through the tree and then we can worry about, how we build the numbers later, just so I could see what you knew.
Okay. All right. I see what you're saying. Yeah. Because my okay, because my thing was traversing through the tree right here. But okay, so I'll
So
make sure.
I'll be honest, that doesn't make sense to me.
Okay,
Like having a stack for a depth first search makes sense. We add a node to it, and then we add root to it, and then we have it has its left child. So we look at the left child, and then we push the left child on it to look for its children. That makes sense. But I guess you called it binary tree node stack tree, and then we're pushing. I mean, I guess you're pushing the root on it.
right.
Okay, and then we would also want to then recurse or add the left leaf node to that stack, and push and pop. We got to have a like while stack not empty kind of idea here. So I think you definitely need some practice with trees. Like I said, recursion is a good thing to practice as well because it lends itself so cleanly to trees. If you push recursion to prod, someone's going to hit you with something, they're going to fire you, right? You don't do that. Most people aren't using trees in their day-to-day job, so that when you see some new problem, you may not know exactly how to solve it, but you might already have some trick you've seen that will simplify it or help push you in the right direction, right?
Right. Exactly.
All right. You have a good day.
You too. Thank you. Thanks for your time,
No
Steve.
problem. Have a good weekend.
You too. Thanks.
Bye.